Alright, ladies and gentlemen, in this video we are going to find the zeros and state the multiplicity of the zeros. That sounds kind of complicated, doesn't it? Well, we're going to start with something like this. It's not as bad as it looks or sounds. Okay, y equals, let's just say, x plus 2, and then let's say x times x minus 1 with squared. Okay, so what does multiplicity mean? Well, multiplicity has to do with how many times a factor occurs. In other words, how many identical factors there are. So, if you look, this x plus 2 occurs once because there's no exponent. But this x minus 1 is a factor that is twice, because it's really x minus 1 times x minus 1, hence squared. So it has a multiplicity of 2. So when I take my x plus 2, set it equal to 0, and I solve for x by subtracting 2 from each side, I get a 0 of x equals negative 2. This has a multiplicity of 1. Why? Because it occurs only once. When I take my x minus 1, set it equal to 0, and solve for x by adding 1 to each side, I get x equals 1. But because of this exponent, it has a multiplicity of 2. A lot of times I'll just write it M-U-L-T, 2. What does that mean? It means that this is twice. So our zeros really are x equals negative 2, and then x equals 1, and x equals 1 again. Now, if this exponent were a 3, then it would be a multiplicity of 3. So that means it would happen 3 times. But since we have a 2, it happens twice. X equals 1 twice. Now, how in the world does that happen? Well, let me give you a little bit of a visual for this. Now, you know the zeros are the places where it crosses the graph, okay? Now, this is going to be generic graph, okay? So don't expect this to be an accurate graph. In fact, my lines probably aren't even anywhere near straight, okay? But this is just to give you a visual of what this looks like. Alrighty? Whenever you have an odd multiplicity, it means it crosses the x-axis at that location. Whenever you have an even multiplicity, it touches the x-axis and turns around and goes back. Oh, so crosses at odd multiplicity, touches at even. Now, we have to have a positive leading coefficient because there's no negative out front. So this 2 plus 1 makes 3. Our degree is 3, so it means it's going to start from down here. It's going to cross up here, curve, go around, and go back up. So let me get my points on. I'm going to actually just change colors so my graph sticks out a little better. Okay, at x equals negative 2, I'm just going to put a dot here on the x-axis. It will cross. But at x equals positive 1, it's only going to touch. So it starts way down here somewhere. It crosses at x equals negative 2. It curves somewhere, goes down. It just touches the x-axis at x equals 1 and turns around and goes back. Okay, with double arrows here. That is the basic shape of our graph. Remember, the only 2 accurate points are here and here. All the rest of this is just figurative. We don't know exactly where it curves for its maximum value, but we do know that this is a minimum value at x equals 1. So that's really pretty cool. From x equals 1 comma 0 is a minimum, a true minimum, or relative minimum, I should say, because there are no true minimums because of the double-ended arrows. So that's pretty cool. So remember, odd multiplicities cross the x-axis. Even multiplicities touches, turns around and goes back. Alrighty. Have a good one, everybody. Bye-bye.